In this video, I'm going to sketch the graph of the vector-valued function r of t with x component negative 2t plus 2 and y component t minus 3. And I'm going to use the process explained in the notes and learning goals. The first step in that process is to create a table of values, which I will do here. So looking at for t equals negative 2, x of negative 2 is negative 2 times negative 2 plus 2, otherwise known as 6. That's how I get a 6 right here. Y of negative 2 is negative 2 minus 3, which is negative 5. Continuing in this way, for t equals negative 1, t equals 0, t equals 1, and t equals 2, we get 4 and negative 4, 2 and negative 3, 0, negative 2, negative 2, and negative 1. All right, so now the next step in the process is for each entry in the table, graph the terminal point of the vector. All right, so what that means is r of negative 2, we see here actually just this spot in the table here, this row is 6, negative 5. So going over to the point 6, negative 5, 1, 2, 3, 4, 5. So technically, right, this is a vector, right? And we think of it as, we have this vector here that points to the point. It points to that point 6, negative 5. And you can think of this point as a terminal point, as the terminal point of this vector written in component form 6, negative 5. Remember, the initial point is the origin. So we have the initial point origin, terminal point 6, negative 5, and the process in the notes and learning goals says to just graph the terminal point. So you don't have to graph this green vector. You just have to graph the terminal point, which is the black point there. So let me get rid of this thing there. And when you graph this point, it's a good idea to label its t value. So t equals negative 2 here. Okay, so doing the same process, thinking of it as we have a vector that's pointing to or drawing the point itself. Moving to t equals negative 1, we have 1, 2, 3, 4, negative 4. So 1, 2, 3, 4, 4 down. And that's the point t equals negative 1. At t equals 0, we get 2, negative 3. So that's t equals 0. At t equals 1, we have 0, negative 2. So that's t equals 1. And at t equals 2, we have negative 2, 1. So negative 2, negative 2, negative 1. I apologize. So negative 2, negative 1 there. That's graphed when you put t equals 2 into our vector valued function. Now, third step in the process, connect the dots. So now I'll connect the dots with a smooth curve. In this case, it appears that our curve is a line. Something like that. Next, we want to include arrows to indicate the direction of increasing t. All right, so notice that first we start with t equals -2, then -1, then 0, then 1, then 2. So that tells us that the increasing direction is that direction. And that's the process. Now I have sketched the graph of the vector valued function r of t. Now just for one moment here, let's think about the fact that it sure looks like this is a line, right? And in fact, it is a line. And we can see that by rewriting r of t like so. So to get from there to that, I used our rule or definition for vector addition. Now using our rule or definition for scalar multiplication, I can pull out the scalar t. And you see that in fact r of t, our vector valued function r of t, can be put into the form of a line, of a vector described line. So in fact, it makes sense that it is a line.